one thing I've noticed that I had to think about and nag about with you guys the other day was that coefficient has to be the same size. I could say same size and same sign if you're using the formula. There's no way around it. So if one of them was -2, the whole thing's wrong. So you could have the same sign, same size. So you can be really quick at putting the numbers in and say D1 and D2 as those. By the way, some people will write them on the other side of the equal signs. So it doesn't make any difference. Would it matter which one is D1 and D2? No, because if it's 4 take 9 or 9 take 4, it's irrelevant. So if you wanted to, you could just go 5 instead of doing that. And the square root of that is, that's a 2 squared, a 2 squared and a 1 squared. So you could shortcut and go 2 squares for, imagine how much you can shortcut this. You can get this down to seconds. And that's a 4, that's a 1. So we've just got 5 on the square root of 9, which is 3. So the formula in itself is really, really good. But I think we need to think this through. So I had any 2 planes anywhere, so I have that plane there, I have that plane there. Like if I can get that point and go across perpendicular and get that point there, then I can use the distance formula. So, the other day we were talking about how do you get any one point in any plane? Let x equal 0, let y equal 0. So if I call this, for example, plane 1, and I call that plane 2. So if I want a point in that plane, I can let x equal 0, I can let y equal 0, and then I get z equals 4. So 0, 0, z equals 4. So I've got a point in the plane. I'm going to call it A. Point A is 0, 0, 4. What is that point in terms of concepts on x, y, and z?
The z-intercept.
Z-intercept. And why did I go 0, 0, 4? I could have gone y 0, z 0. I could have done whatever I wanted. So I just chucked the first 2 in. I've got a point there. Now, that's that point there, A. So I've got that as 0, 0, 4. And I want that point there. But I can't get that point there until I get that vector there. So how do I get a vector line, the equation of a line in 3D? Same as in 2D. I need a point, and I get a lambda of a vector in the direction I want. So how do I get the equation of that line there? I've got a point, which I know is 0, 0, 4 there, plus I want the direction of that vector, and I had a 3 there when I should have had a 2. So go back to here. This plane here has got a 2, a 2 and a 1. So that's a 2 and a 2 and a 1. Because they are the perpendicular to that plane. So now I've got the line perpendicular to that. I want to shortcut that. I just want to write that as 2 lambda. I want to write that as 2 lambda. I write that as 4 plus lambda. Okay? So that's that here. 2, 2, 1. Now 2, 2, 1 is the vector. The whole equation is 0, 0, 4 plus lambda of 2, 2, 1. Which we can then just write as. Are you comfortable? You know what you're doing already. You can do it again. So now we go to substitution. And what do I do? Substitute R equals, I'm going to write it out in full for a moment. 4 plus lambda into what?
Equation of the plane.
Equation of the plane. Which plane? Pi 2 into pi 2, which is R times by 2, 2, 1. And why do I change it to that form?
It makes it easier.
It's quick and convenient. It's much easier. So now I put the R in there, so it's a straight substitution. 2 lambda, 2 lambda, 4 plus lambda. Simple. Multiply the I's, multiply the J's, multiply the K's. Could really shortcut this. 9 lambda equals 5, and lambda equals 5 and 9. So, what's that lambda got to do with what's happening in the question?
You can get the point of intersection.
That's right. So I get that point there using that lambda. So now I've got to substitute that back into that line. So literally there. So I could have written it as 0, 0, 4 plus 5 ninths of 2, 2, 1. And you can see it's pretty long-winded. So doing it that way is so quick. But the understanding, I think, is important. So I'm going to come back to that. So what have I got in my position? I want actually, I'm going to write at this point B. I want point B. And that's going to be, I could just go to here, and I can go 2 times 5 ninths, 2 times 5 ninths. So I could have just written that straight down. 4 plus 5 ninths. And what have I got? 10 ninths. Don't simplify it. That's terrible writing.
10 on 9, 10 on 9,
And the other one?
4 and 5 on 9, so that'd be 41 on 9.
Yeah, sure you're right?
Yes.
You are. Now, here's the big question. We want the distance from point B to point A. So distance is point A minus point B. So you could write them as RA and RB. You can do all sorts of things if you wanted to be fussy. I could go position A and subtract position B. So what's point A? 004 minus what?
10 on 9, whatever, next one
Bit
is.
yucky, isn't it?
Mm.
But then it turns out really nice. Well, how does it turn out really nice? So that's just 10 on 9. So if I wrote it that way, let's be fussy for a moment, I wrote it that way. It's writing too much in. It's actually minus 10 on 9, isn't it?
Yeah.
And they've been minus. So it would have been nicer if I would have went that, subtract that, instead of that, subtract that. So it's always a good point to check. So that's minus what?
5 on
Hopefully we made no mistakes. It looks correct.
9.
So how do you get the magnitude of the vector with those three?
Pythag.
Yeah. We're back to Pythagoras, so we've got the distance is the square root. This is where it works out really nice. 10 ninths squared. I'm going to bother to write it all. I didn't have to write minus 10 ninths, but I probably should. Plus 5 ninths squared. And watch how easy and nice this drops out. What have we got? 100 on 81. Plus another 100 on 81. Plus 25 on 81. And this is what's beautiful. Square root of 225 on the square root of 81. So then you're left with 15 over 9, which is 5 over 3. So the formula, if you're good at it, you can do it literally in 20 seconds, or you can go through that process. But imagine if you did that process all the time.
Does the waste accept that formula though?
Absolutely.
Oh, do they?
Yeah.
So if they say calculate distance between these planes, show working,
Yeah.
that can be working?
And all I did was really one line of working.
Yeah.
So remember, if it's in Western Australia, if it's 2 marks, you don't have, or you could actually sit there and go, the distance between those two is 5, and then you can go 4 and 4 and 1's root 9. You see, you could have just written 5 over 3. No working at no nothing, getting the marks. But the moment they go 3 marks, you've got to do something. So it's not, you get no marks for the formula. So you don't have to write the formula down, you can just go put the numbers in, write the answer down, 3 out of 3. The problem is making a silly mistake, of course. I started mucking around, making up other questions I could use for revision on another day. I'll walk in and do it. So, process, you okay? Do you see the process in your head though with this? Yeah, you can just go that.